This first question says the point -4, 3 lies on the terminal arm of an angle in standard position. What is the exact value of each trig ratio for the angle? So I want to think about what this is going to look like. Here's my x and y axis. The point is -4, 3. So which quadrant is that in? 2. So you have an angle in standard position like that with this point A here. The angle in standard position is there. So that would be what we would call theta. But we're going to talk about everything in terms of the reference angle, the same as we do with the special angles. So what I'm going to do actually is turn this into a right angle triangle and look at the reference angle in there. That should be R, theta R. It's just too small to see. So here's the reference angle, here's the triangle. What's the length of this adjacent side? -4, or we could just call it 4. And the length of the opposite side? 3. And how about the length of the hypotenuse? 5. And how do you know it's 5? Because it's a Pythagorean triple, right? 3, 4, 5. But if you didn't know that, how could you figure out the length of 5? Yeah, Pythagorean theorem. So a squared plus b squared equals c squared. And you'd find the length of that hypotenuse by doing 3 squared plus 4 squared. And you'd find out that c equals 5. Once we have the 3 side lengths, then we can find what it's asking for, which is the exact value of each trig ratio for the angle. So what are the trig ratios? Sine, cosine, tangent. And then the reciprocals. So sine, cosine, tangent, and then cosecant, secant, and cotangent. I want to leave a little more space there. Okay, once we have that, if I want to find the sine of that angle, it's just opposite over hypotenuse. So it's 3/4. That's for the reference angle.
3/5.
Oh, sorry, opposite over hypotenuse. 3/5. You're right. Cosine is going to be adjacent over hypotenuse, so it's 4/5. Tangent is opposite over adjacent. 3/4. That's for the reference angle. Then we need to consider the sine. Sine is in positive, negative, not as in the sine ratio. In the second quadrant, sine is positive, which means that cosine and tangent will both be negative. Then the other 3, really easy to find. They're just the reciprocals. Cosecant is the reciprocal of sine. So it's 5/3. Secant is the reciprocal of cosine, so it's -5/4. And cotangent is the reciprocal of tan, so it's -4/3. Here's the other one that I wanted to talk to you about today. Identify a measure for the central angle if the terminal, that should say terminal arm, passes through this point. -1/√2 and 1/√2. So we're trying to figure out what's the angle when it passes through that point. So again, if I kind of look at where that point is, well, it's negative, positive, so it's like it's somewhere in there, right? How am I going to figure out what the actual angle is? In radians.
3 pi.
So you think it's 3 pi over 4. Why do you think it's 3 pi over 4? You're looking at your unit circle? Okay, so let's not look at your circle because you're not going to have that for a test or your exam. If you're not looking directly at it and picking the point from your unit circle that you already filled in, how are we going to figure it out?
third side.
Oh, yeah, we could do that.
And then using one of the ratios to find the angle. The inverse of the ratio.
Yes, that will work. So he's suggesting that we draw in the triangle and then do 1 over root 2 for this side, 1 over root 2 for this side, and then find that other side using the Pythagorean theorem. That'll definitely work. That's a great idea. It's not the way I was going to do it, but that's okay. Let's just try it and see if it works. So we want to find that third side. So we're going to go 1 over root 2 squared plus 1 over root 2 squared equals c squared. So 1 over root 2 squared is 1 over 2, right? So what's c equal to? C is equal to 1. So then you're saying, can we just pick sine? Pick whatever we want. Sine's the one that's positive there. That's why I'm thinking we'll pick sine. Sine of theta is opposite over hypotenuse. So 1 over root 2 over 1, which is just 1 over root 2. And then what was your idea to figure out the actual angle, Akash?
Just use like the inverse.
Oh, on your calculator?
Yeah.
Okay, so if we do that, so you're saying do inverse cosine of 1 over root 2. And so you could do it in degrees. It'll give you 45 degrees and then change it to radians. Or you should know that the angle that has a sine of 1 over root 2 is pi over 4, right? Because the one that has a 1 over root 2 has 1 as the opposite and root 2 as the hypotenuse. So the reference angle is pi over 4. And then because we're in that quadrant, it's actually 3 pi over 4. I think I could save us a little bit of work here because of the 1 over root 2 here in the coordinate. That's already, we know it's going to be a special angle. And really what we did with all of this work here was figured out that the sine of the angle is 1 over root 2. But if you remember that when you have a coordinate, it is cosine sine. We already knew that sine was 1 over root 2. But that's okay because if it wasn't one of the special angles, you would still have to go through all of that. And it's great problem solving. So when you get to your exam, you're going to have questions where there are multiple ways of solving. And some ways, like you might come out of your exam and somebody will be like, oh, I did this for this question. And then you're going to be like, oh, well, I did this little tiny thing. And you probably both get to the right answer. But because these are side lengths that are on the special triangles, we could skip those steps. If they weren't, we couldn't.